Use the formula for the sum of the first n integers and or the formula for the sum of a geometric sequence to evaluate the sums in 20 through 29 or to write them in closed form. Now I'm actually going to solve this two different ways. One way is to rely on the formula and the other way is to do something I think a little clever. So first we're going to write this as a sum of terms. Now each of these terms represents a multiple of 5. The first term represents the first multiple of 5. So our index variable is going to be k, which iterates from 1, and we'll figure out we'll figure out the upper bound for the index variable later. And then the rule to identify each of these terms would be 5 times k. So whatever k is, if k is 1, then the first term is 5. If k is 2, then the second term is 5 times 2, which is 10, and so on. And now we can tell what the last value of our index variable is going to be by solving 5k equals 300. In this case, we can see what k would need to be in order for 5k to be 300, and that would be 300 divided by 5, which is 60. So that means the upper bound for k is going to be 60. Next thing I'm going to do is I'm going to rewrite the summation by pulling out this 5. We can't use the rule yet unless we first pull this 5 out of the series. This is equivalent to factoring out a 5 from each of these terms. So instead of 5, 10, 15, 20, it'll be 1, 2, 3, 4, and so on. And so this is equal to 5 times the series, all else equal here. But instead of 5k, now this is just k. And we can use the formula to rewrite the summation in closed form. This is 5 times the number 60 times the number 60 plus 1, which is 61, and then all divided by 2. And that's using the formula for the sum of the first n integers specifically, which is 9,150. So that's what I get when I add up all of these numbers here. Now let's say we didn't have this formula here. Maybe you don't know that the summation from 1 to 60 of k is 60 times 60 plus 1 all over 2. Maybe you don't know that fact from the formula. How can you solve this problem differently? Well, the trick here is to write out our series in expanded form, and I'm actually going to write the last 2 terms in this series. So the second to last term would be 295, and the last term would be 300. And what I'm going to do is I'm going to rewrite this series, but in reverse order. So the first number below will actually be 300, and the second number below will be 295, and so on, all the way until we get down to 10 plus 5. So now what I'm going to do is I'm going to add all of these numbers together. But keep in mind that each number is represented twice in this addition, which means at the very end I'm going to divide by 2. But what I'm going to do is I'm going to add all these numbers first. So the way I'm going to add these numbers is I'm going to add vertically. So 5 plus 300 is 305. 10 plus 295 is also 305. 15 plus 290 is 305. 20 plus 285 is 305. All of these numbers are 305, including the last 2 numbers here. 295 plus 10 is 305, and 300 plus 5 is 305. So now the next question is, how many 305s do we have here? Well, there are 60 total terms, which means that this is 60 times 305. However, since we counted each number twice, that means if we want to actually calculate the series where we count each number exactly once, we would have to take this result and divide by 2 so that we don't double count anything, so that we can get rid of all of the copy. And this is 9,150. So I think it's important to understand both of these techniques of solving this problem. Thanks everyone, and I'll see you in the next video.